This is page 4, number 11, giving it its own separate treatment because it's kind of a pain. You have a kind of big number there and a higher index, fifth root. So two common approaches to this. I'll show you my favorite first. We're interested in factoring this so that one of the factors is a perfect fifth power of something. If you think about what is a fifth power, 1 to the fifth, 1 times 1 times 1 times, that's just 1. 2 to the fifth is 32. And 3 to the fifth, these get large in a hurry, because they're fifth powers. We're already past the 192. That's certainly not going to factor out of 192. Can we factor a 32 out of 192? Let's see. I'll take a little basic calculator. 192 divided by 32, 6. That's wonderful. So we can factor the 192 into 32 times 6. And again, why do I want to do that? Because 32 is a perfect fifth power. The fifth root of 32 will be 2. And then the v to the sixth, I need, as a few days ago, as large an exponent as possible here that will be divisible by the index 5. So v to the fifth, v to the first. So this becomes a 2. This stays with us. This becomes a v to the fifth divided by 5. Fifth divided by the index 5, we get v to the first, or just v. So these two things came out. I have 2v on the outside, and what's left over under the radical? Fifth root 6v. Now, if you didn't quite follow this argument, another thing you can do with just the numerical part of this, the fifth root of 192, take the 192 and factor it into prime numbers. Make a factor tree. You could take 192 and divide it by 2, and you get 96. And that's a prime number. This is not a prime number. You keep going. There's 2 again. Divide by 2 again, you get 48. And 48 breaks down into 2 times 24. There's another prime number, another 2. And 20, this gets a little tiresome, but it works. 2 and 6. And finally, 2 and 3. So now we've got all prime numbers, right? So we got 2 times 2 times 2 times 2 times 2 times 2 times 3 is 192. Written in a more compact form, it's 2 to the sixth power times 3. Now, why were we doing this? Because we wanted to get something we could take the fifth root of and not get a decimal answer. So just like we would do with the x, I'll take this 2 to the sixth and break it down into 2 to the fifth times 2 to the first. Okay, and this 2 to the fifth becomes just a plain old 2, and we still have under the radical 2 times 3. So there's the numerical part of the result explained a different way. Okay, hopefully one of those is useful and comfortable for you.